Hi there, everybody. I'm going to give a talk on kind of best practices for debugging and monitoring on Kubernetes for services. This is going to end up being a Linkerd demo at the end, but I like to do things other than just talk about a product and talk a little bit more about how to think about your services and how to think about monitoring in kind of a cloud-native world. A little bit of background for me. I'm a software engineer at Buoyant, which means that I have the coolest job in the world. I get to do open source all day, and I don't have to worry about making any money. It's really fantastic, let me tell you. I've got my Twitter and GitHub up there. I also am a massive troll in the Kubernetes Slack, so if you have any questions, feel free to ping me there. And I wanted to show off my favorite tweet in the whole world. We replaced our monolith with microservices so that every outage could be more like a murder mystery. And I think this is something that folks don't really think about much. In fact, what I've been seeing is that it's not just a let's move to microservices, it's a let's move to microservices and get on Kubernetes and go to the public cloud all at once. And as soon as you're changing that much, it's less of a murder mystery and more of an inquisition in my mind. But before we get into that, let's talk a little bit about what problems actually need to be solved. There's a lot of times, like we were just chatting, everyone says a service mesh, you've got to have a service mesh, but they don't actually talk about what problems they're trying to solve. And so I kind of like to go about that from the monitoring perspective. And towards that end, I really have two kind of ways to look at monitoring and observability. One is for alerting. You want your alerting to tell you about downtime, to talk about exceptions, and to go and validate your service level agreements. Those are things like my service has got a latency that is valid. Other than that, you don't want to get woken up. I don't like to get woken up because a node rolled. That's the whole point of being cloud native. I just want to know that my service is down. However, there's another important type of observability, and this is kind of like why I like to talk about the problems. It's the forensics. Once you have downtime, you need to go figure out why you have downtime, what the problem is. And there you need to go and actually look into things a little bit more deeply. You want to understand if there's memory leaks. You want to know if there's performance issues, if your database is having problems. And you want to go and look at environment-specific failures, like differences between public clouds. So let's dig in a little bit on the monitoring for alerting side of things. So downtime. Everyone do external monitoring. I've got Pingdom down here at the bottom, but pick your own external monitoring of choice. If you're doing it internally, there's no guarantee that the internet actually works. And let me tell you, it likely isn't. The other big one is in Kubernetes. This is best practice, but I like to tell everyone about it. And that is use liveness probes and readiness probes. Liveness will restart your pod. Readiness will take it out of a load balancer set. Both of those are super valid for doing downtime, making sure that it's not going down. And then there is kube state metrics, which is a monitoring system that you can go and add in there as well. And then we get to exceptions. I happen to love Sentry. There's a million ways to do this. But you definitely want to go and have your exception monitoring in there and then make sure that you go and fix the exceptions so that you don't ignore it forever after. Not that I've done that before or anything. So now let me talk a little bit about what the Google SRE handbook says you should be actually monitoring. They've said that there are 4 golden signals. These are the only things you need to monitor. Everything else is nice to have. Number 1 is latency. What's the request and response time for your service? Number 2 is traffic. How many requests per second are you getting? Number 3 is errors. How many of your requests are actually getting failed? Number 4 is saturation. Saturation is a little bit of a hybrid metric. And the idea behind there is you've all seen it as your load goes up, your response times start to do the hockey stick. And there's saturation is the point at which one extra request would go and take your service and destroy its latency. And speaking of latency, I'm a huge latency geek. There's a link to a post at the bottom here that's everything you know about latency is wrong. It's really fantastic. It's written by the CTO of Azul Systems. They do JVM tuning. and it's really fascinating. But if I go have you look at the graph over there, let's talk a little bit about latencies. So you've got normally we talk about latency in a P50, P90, P99 world. And what that P99 latency is, percentile, 99th percentile. And that means that 1 out of 99 requests experience a latency that is that or higher, which means that 1 out of 100 requests get that latency. Thinking about it that way, you're like, it's not actually that big of a deal. But in this table, if you look, to load Amazon.com, it takes 190 requests, which means that the probability that a user loading Amazon.com once will hit a P99 latency is 85%. That's how important it is to go and monitor your P99 latencies over an average or anything else. And I've got it up here. The users see the responses. They don't care about your CPU or memory usage. They don't care about your bandwidth usage. They really just care how long it takes for their browser to load up. In fact, fun anecdote, I know someone who works at YouTube who went and put together this super lightweight YouTube. They reduced the bandwidth and latency on it from 5 megs down to 500K. And they saw this really interesting traffic pattern where they started to fail a ton more requests. And the reason they were failing the requests for this smaller, faster YouTube was because it was getting loaded in parts of the world who don't have fast bandwidth like us. And so it took the site of YouTube from being something that no one could use down to something that almost everybody was using in the world. It was one of those crazy ways of looking at it. So let's talk a little bit about the monitoring for forensics. This is where we get into the great stuff that Kubernetes gives us out of the box. Metric server gives us CPU and memory. We get it for pods and nodes. It's fantastic. I use it all the time. kubectl top is my friend. And then I'm going to talk about my other favorite CNCF project, Prometheus, which is absolutely fantastic. It is the Kubernetes standard. There's a Helm chart. It's easy to install. If you're not using it already, please do. It's a fantastic, absolutely fantastic project. And it gives you most of what you need for monitoring. You get alerts. You can do extra metrics. You get time series. And if you go look at the node exporter stuff, there's all kinds of interesting, unique things that you get out of that. Then let's talk a little bit about application instrumentation. So Prometheus, because it's not part of your application out of the box, will give you the CPU and memory, TCP, everything that you can get out of the kernel, but it won't be giving you those layer 4 to layer 7 details like request and response times, where you actually need to understand the HTTP protocol. So you can go and put that into your application. Obviously, I'm going to show you a way that you don't have to, but monitoring or instrumenting your application is still great. If you're doing something like a Kafka queue, you're going to want to count the queue length. If you're going and measuring, credit card numbers going through, there's a million different things in your application that's business specific that you want to go and do application specific monitoring for. And it's really, really easy with Prometheus. Again, in the Kubernetes world, it's an annotation on your pod, and suddenly it gets scraped and you see the metrics the way you would expect it to. And then the last one, I hope we're all using a log aggregator of choice. Just got to do it, best practice. Because when the service goes down in the middle of the night and you don't want to get up, you're going to want to go back and do that forensics on the logs. Remember, getting extra log lines isn't what you want to get woken up for. You want to go back and dig into them to understand what the problem was at the time. So I've got an application. This is running now. We're actually going to debug this. It has an error. If you click around and do some voting, you'll find out why. Please don't destroy it. It probably won't hold the load up right now, but we'll go and start to play with that as part of my demo. Here is the architecture. It is perhaps the world's simplest, most ridiculous microservice. We have a vote bot that does nothing but vote for emojis. We have a web front end, which is the screenshot that you just saw. Then we have a emoji service that's kind of the database for the emojis, and a voting service that is the database for how many votes are there. The vote bot to web connection is HTTP1, and web to emoji and voting is gRPC. And I hope some of you found it. For reasons unbeknownst to me, whenever you vote for the donut, it ends up in a failure. It's very sad. I might have made sure that it wasn't the unicorn, just saying. So here's what we're going to do. I'm actually going to go through and figure out what it is that's going wrong with that. So kind of an interactive debugging session while we're standing here. So the first one is the service running? I've got a picture of the Kubernetes dashboard, but I'll actually pull the dashboard itself up here. Let me put this down for a second. And if we look, I've got my Kubernetes dashboard. That's a whole lot of green. CPU looks fine, memory looks fine, everything looks fine. As someone who's gotten a call from the CEO because his friend went and clicked to vote for a donut and failed, this is probably one of the most frustrating problems that I have to debug, because all of the monitoring is saying everything's okay, what's going on? I don't understand. It's, a page for the new thing that got rolled out. Well, remember on that dashboard, the deployments looked fine. Everything is green. Kubernetes thinks it's green. And we have liveness and readiness probes already configured on these applications. So again, it looks okay. But if we look in the logs, something's failing. This actually happens to be a pretty verbose, though wonderfully indecipherable Go log line. But okay, something's going wrong. We found it. But what is actually happening? And that's what I'm going to walk you through with Linkerd. And Linkerd is a service mesh. Service meshes do many different things. I like to talk about Linkerd as microservice forensics. This gets back to that idea of microservices being a murder mystery when something goes wrong. Linkerd and the service mesh really came out of Twitter as they moved from the monolithic Rails app into a microservice world, because they needed a common observability platform to go and help the engineers understand what's going wrong on a day-to-day basis. So how do we do it? Well, this is the service mesh and Linkerd at its simplest. There's a transparent proxy. It's a container. It goes in your pod. And because of the magic of IP tables, all of the incoming traffic goes through the proxy and all of the outgoing traffic goes through the proxy. Since most of the traffic inside your data center is unencrypted, we can go and look at all of the requests. And Linkerd is aware of the HTTP protocol, in fact, gRPC as well. In fact, we have a couple other protocols we're working on. Because of that, we can do protocol level specific instrumentation, which is where you start to see all of the microservice forensics that I've been talking about. But that's just the data plane. If we pull out a little bit, you don't just want to have a proxy, though we're going to be hearing a little bit about Envoy later as a proxy. You actually want to have a control plane because, for example, your metrics, you don't just want IP addresses, you actually want to track those back to your pods and your deployments so that it's a little bit more understandable. In Kubernetes, you want to go do service discovery. You want to have your Prometheus to go and record everything. So that's really how that all plays together. And out of the box, we ship with a dashboard. I'm going to walk everybody through that a little bit later. We have a controller that does the service discovery and everything around the actual operation of the service mesh. We've got a Prometheus that holds all of the data. And we've got a Grafana that comes with dashboards out of the box. And that Grafana dashboard is what you'd put up on a TV to go and watch and make sure that you feel good about how your service is actually running. So as a friendly reminder, please feel free to vote. Otherwise, the unicorn is going to be the happiest. Oh, I just gave it away. Let me start in on the demo here then. And to get started, I'm going to have to install Linkerd. But before I do that, I'm going to go do a check. And what this does is every Kubernetes cluster on Earth is a snowflake. I don't care what anybody tells you. They're snowflakes. Not only that, but your service account and what you're actually accessing the cluster with is as well. And so we've gone through and done checks before you get to the service, before you even do the install, for things like, do I have permissions to create namespaces? can I raise the netadmin capability correctly? Is it on the latest version? So you can feel pretty confident that once you do an install, everything works. And to do an install, we don't like modifying your cluster for you, so we just output YAML. Most of the Linkerd CLI commands that would do a write operation just output your YAML, so you can go and validate that everything looks good and that you feel comfortable with what you're about to do. And since this is a demo, obviously I feel comfortable. So let's just kubectl apply that. So this is pretty much all of the control plane. Most of this at the top is role bindings for RBAC to make sure that it is very, very specific. We've just recently done MTLS, which uses service accounts for identity. And so every component in the control plane has its own service account, needs its own RBAC. Hopefully, once with all of that talking, my check here is going to pass. But just like we did a pre-flight, we'll now do a post-flight and make sure that everything comes up. Once our control plane pods actually boot, we'll be able to go and see how everything is running. And while that's happening, I'm going to go over to a different tab and get ready to do the dashboard. So our install is all happy. Let me pull up the dashboard for everyone. So this is our dashboard. I have not added anything to the data plane yet. You'll see that the Emojivoto namespace is here, but we're not actually showing anything for it. The fun thing I like to show here is we dog food our own stuff. All of the Linkerd control plane components use the Linkerd data plane, and so we actually use this to debug. In fact, one of the big focuses for Linkerd, because I really hate reading bug reports, is the observability so that we can help users figure out what's going wrong. I like to joke that if something's wrong, it's always DNS's fault. Once you put a service mesh in, when something goes wrong, it's always the service mesh's fault. And to be honest, it is 50% of the time. So take that with a grain of salt. So now we've got our control plane up and running. The next step would be to add our application to it. So give me just a second here. So what I'm doing here is just getting the YAML back from Kubernetes. Now, if I had a Helm install or I had a bunch of YAML files, I could go and add the Linkerd proxy to put it into the data plane in a bunch of different ways. I'm super lazy, so I'm just going to get it back from Kubernetes. And then I'm going to pipe this through Linkerd inject, which is going to add the data plane in. And in fact, just recently we moved over to using auto inject for everything. So all this Linkerd inject is going to do is actually just add an annotation to your pod spec that says, please add the proxy to that. The reason we're doing that is so that your deployments are pristine. You don't need to go and deal with diffing between your Git and your actual running system. And we'll go modify the pod specs themselves. So just to show you that nothing fancy is happening, we added in the annotation, and just like we did the pre-flight checks for the control plane, you'll see we're also doing it for the data plane here. And in fact, if you're using something like host networking that we don't support, you would go get an error. So let's just add this in. And because of the magic of Kubernetes, we now just kicked off a rolling deploy. So if any of you were still voting, you would be able to continue to do your votes without any problem. And now let's go back to the dashboard. And within probably about 60 seconds, we'll see some stats start to pop up here. You'll notice that I did this without modifying my code at all. If you think about this from a user's perspective, it's taken it so that your application developers don't need to argue with their product manager anymore to go and get something implemented. They can simply throw this in and instantly start to see stuff. In fact, we talked a little bit about errors being hard to track. You'll see some reds pop up immediately on the dashboard there. And in fact, that's where we're going to go take a look next. So if we go through to the web deployment, you'll notice that we have a topology immediately. Going back to that murder mystery, the topologies happen to be the thing that most folks want to know about their services, so how they talk to each other. The Calico node here is actually out external traffic coming in. That's how GKE does its stuff. And you'll see that we've got about a 96% success rate on web and 100% success rate on emoji, with, again, about 96% on voting. So just by looking at this, we've pretty much already got a feel for what's going on. Because emoji is super healthy, we can kind of think a little bit about, well, is it voting? And if we scroll down here, we have top for your cluster. So this is all of the top requests in your cluster, live. We're using the tap feature for that. And you pretty much get to see exactly what's happening there. In fact, if we go take a look, you'll notice that we found the culprit immediately. Voting has got, the donut has got a 0% success rate. And if we want to dig in a little bit more, instead of seeing the aggregates, we can actually see the live traffic itself. Oh, let me open this up here. You'll notice that the HTTP status is 200, but the gRPC is unknown. gRPC uses HTTP 2. It's where it does most of its magic, and it always returns a 200, whether there's a success or not. And so because we're gRPC aware, we can actually classify these as failures. And that's it. It really is that easy. I've had some users roll out new functionality, new applications, and start to see it become issues. They injected Linkerd in, figured out the issue, and actually removed it immediately because they didn't need it anymore. And with that, yep, sure enough, that's the culprit. We now know who it is. You can either go modify the code or update it yourself, pretty much however you'd like to go about that. So this is the thing that I actually get the most excited about. With a solid level of observability in your system, you can start to build really cool stuff. I've got auto-scaling up here. I actually did a talk at the last KubeCon about auto-scaling on latency instead of CPU and memory. You can do alerting. You can do anomaly detection. Prometheus lets you do that basically out of the box. You can start to do your capacity planning. There's going to be a demo at this KubeCon by the KubeCost folks that shows how to do chargeback. So they're actually going to be showing off pricing per request for public cloud deployments, which is just mind-blowingly awesome. And it's all built on top of the visibility that you get from Linkerd. You can do intelligent deployments, something like a canary rollout that automatically rolls back if it sees any issues. And obviously the most important one that's always a pain, the SLA compliance. And that's it. I think we should probably go on to the talk, but I'm going to be around after. And so if anyone has any questions whatsoever, please come and chat with me about Kubernetes monitoring, service meshes. I like all of the technology. Thank you very much.